Welcome to brief presentation of common problems and solutions in EMI or EMC. EMI or EMC tests are differentiates in two categories that are the emission and immunity. That is given in the tree diagram. Conducted emissions are the radio frequency noise that is created by a device in the form of electromagnetic energy. It is conducted onto the power supply cord, and that noise is very harmful to other devices. For checking the strength of the conducted noise, conducted emission test is conducted. Common problems in conducted emission created by device are given below. Switching power supplies and variable speed motor drives produce large noise currents which are conducted out to the load as well as conducted back to the power source. The common mode noise currents are the cause of low frequency conducted emission. The most common noise source is the switching transistor. The bridge rectifier noise will occur at multiples of 120 Hz and is differential mode. Parasitic oscillation also generates large noise. There are different solutions available to remove or minimize the emission of conducted noise from the device. The methods are as follows. Use line filters or total EMI filter or power line filter. Minimize the dV by dt. Reduce the parasitic capacitance. Use filtering to reduce the common mode current on the cable. Use grounding to return the common mode current. Use of shielded power cable on automatic shutdown relay output. Cable will reduce EMI ASD output. Typically shield should be grounded. Use of common mode chokes will attenuate ground-based capacitive noise current. Do not run signal cable in same cable tray as power cable. Put signal cable in separate cable tray with covers. X capacitors are connected between the line phases and are effective against symmetrical interference. Y capacitors are the EMI capacitors that are connected from the input power feeds to chassis ground and are effective against asymmetrical interference. Use synchronizing power modules. Add a choke to the DC output ground lead. Add a common mode choke to the input circuit. Reduce transformer interwinding capacitance. Radiated emission is the radio frequency noise that is emitted by a device in the form of electromagnetic energy. It will be radiated into the air, and the radiated noise is very harmful to other devices. For checking the strength of radiated noise, radiated emission test is conducted. Common problems in radiated emissions created by devices given below. The common mode noise currents are the cause of high-frequency radiated emission. The most common noise source is the switching transistor. The interactions between the power supply and the power line filter. Cables act like antennas for radio noise. It is one of the top failure modes due to high slew rate of signals on the cables. There are different solutions available to remove or minimize the radiated emission noise from the device are given below. Use shielding to return the common mode current. to reduce the parasitic capacitance. Keep current loops small. For pairs of copper-printed circuit board traces, use wide traces aligned above and below each other. Locate filters at the source of interference, basically as close to the power module as possible. Filter component values should be chosen with consideration given to the desired frequency range of attenuation. Keep bypass capacitor leads as short as possible. Locate components on the PC board with consideration given to proximity of noise sources to potentially susceptible circuits. Add a Faraday shield to the transformer. The increasing use of electronic equipment fitted with switch mode power supplies has led to an increase in distortion of the public power supply. Such loads draw non-sinusoidal current, which contains harmonic frequencies at multiples of the 50 Hz and 60 Hz supply frequencies. This can lead to significant currents flowing in the neutral conductor, resulting in cable and transformer overheating. This is also known as phantom power because it has to be transported through cables and transformers, but is not useful. So, for checking the level of harmonic emission of equipment, the harmonic emission test is conducted. Common sources of harmonic generators in equipment are given below. Due to the power electronics components. Due to the arching device. Due to saturable device. Due to the coils, inductors, capacitors. Switched mode power supplies. Dimmers. Current regulators. Frequency converters. Voltage source inverters with pulse width modulated converters. Low power consumption lamps. Electrical arc furnaces. Arc welding machines. Induction motors with irregular magnetizing current associated with saturation of the iron. All equipment with built-in switching devices or with internal loads with nonlinear voltage or current characteristics. There are different solutions are available to remove or minimize the harmonic emission noise from the device are given below. Use harmonic filters. Use isolation transformers. Line reactors. By adding a line reactor or an isolation transformer, we can attenuate harmonics noise. Isolation feeding sensitive loads and harmonic loads from separate sources provides greater system impedance between loads. Flicker is a visible change in brightness of a lamp due to rapid fluctuations in the voltage of the power supply. The voltage drop is generated over the source impedance of the grid by the changing load current of an equipment or facility. These fluctuations in time generate flicker. The effects can range from disturbance to epileptic attacks of photosensitive persons. Flicker may also affect sensitive electronic equipment such as television receivers or industrial processes relying on constant electrical power. The flicker test is carried out to measure the flicker generated by equipment. Common problems in flicker noise created by devices given below. Dimmer switches or when electrical equipment drawing heavy currents are turned on or when being used. During operation of resistance welding machines. Due to motors operation in refrigerators. Due to air conditioners. Arc furnaces are one of the flicker noise sources. Medical imaging machines like X-ray, CAT scan, EMI. Generating large flickers. Flickers are generated by the operation of motors subject to variable loads. When the operation of large capacity photocopiers for remove or minimize the flicker noise from the device, following tricks are very important. Capacitance should be added to the output of the driver to filter out the AC ripple component. Some types of ballasts can reduce flicker considerably. Use filtering. Use of isolation transformers is very effective to stop the flicker noise to transfer on power line. Conducted RF immunity simply refers equipment immunity to unwanted noisy RF voltages and currents carried by its external wires and cables. Common problems in conducted RF susceptibility received by device is given below. By RF transmitters. Received by switched mode power supplies. Other interconnected devices that have electronic activity in RF range. Transformer. Motors. Coils are also generating noise. For remove or minimize conducted RF noise from the device, following tricks are very important. The most effective method for reducing conducted emissions is to suppress them at their source. Use proper line filters. Shielding is important. Also, proper grounding at the required places is most important. Increasing the value of the gate resistor RG in the primary side switcher will increase the rise or fall times of the switching waveform and hence reduce their spectral content. Radiated RF immunity simply refers equipment immunity to unwanted RF noise received by antenna and antenna-like components generated by other equipment. Common problems in radiated RF susceptibility received by device is given below. Natural sources like the sun, the earth and the ionosphere all emit low-level RF fields. Radio and television broadcasting. Mobile phones, pagers, cordless phones, police and fire department radios, point-to-point links and satellite communications all produce RF EMI. Other sources of RF fields include microwave ovens, radar, industrial heaters and sealers, and various medical applications, Wi-Fi routers and equipment. TV video games like PlayStation and Xbox and so on. Streamers. Bluetooth equipment. Baby sense monitors. Smart electric or gas or water meters. Smart TV. For remove or minimize radiated RF noise from the device, following tricks are very important. For noise suppression, use notch filter. The LMS adaptive filter is very useful to prevent the radio noise. Use shielding. The shielding is only totally effective if it is electrically bonded to ground. Install filtering or smoothing circuits across the noise-producing device or contacts. Bonding or grounding should provide a low-resistance path to ground for any radio frequency noise. Use coaxial capacitor for filter the noise. Static charge is an unbalanced electrical charge at rest. Typically, it is created by insulator surfaces rubbing together or Pulling apart. When a static charge moves from one surface to another, it becomes ESD. When that static charge is discharged through the equipment will be damaged. So in the ESD test we can test the equipment capacity for that static charge discharge. Common problems in ESD immunity of devices given below. All materials like insulators and conductors are sources of ESD. Human touch is only sensitive on ESD levels that exceed 4000 volt. Troubleshooting electronic equipment or handling of printed circuit boards without using an electrostatic wrist strap. Placement of synthetic materials, that is plastic, styrofoam, etc. on or near electronic equipment. Rapid movement of near electronic equipment. Due to the human body model. Due to the machine model. Due to the charged device model. Due to the field-induced model. For bypassing the ESD charge to ground or minimize the ESD noise from the device, following tricks are very important. Keep all synthetic materials at least 4 inches away from electronic equipment. When cleaning printed circuit boards, use a spray labeled as non-static forming. When troubleshooting electronic equipment, always wear a static wrist strap that's grounded to the frame of the device. Also, wear the wrist strap when handling printed circuit boards. Treat carpets and floors with compounds that reduce the buildup of static charges. Use static floor mats where necessary. Make sure the grounding system for equipment has low impedance for ESD currents to dissipate to an earthing reference. Use metal oxide varistor MOF to protect the circuit from ESD. Use transient voltage suppression TVS diode to bypass the ESD to ground. The magnetic fields to which equipment is subjected may influence the reliable operation of equipment and systems. These tests are intended to demonstrate the immunity of equipment when subjected to power frequency magnetic fields related to the specific locations and installation condition of the equipment. The power frequency magnetic field is generated by power frequency current in conductors or, more seldom, from other devices in the proximity of equipment. Common problems in power frequency magnetic field immunity of devices given below. Due to the following of ground currents. Due to different types of appliances and lighting. Magnetic field is generated by transmission lines in the overhead distribution services. Due to the underground cables. Due to the operation of bus bars. During the operating condition of transformers. Current flowing through the house cables. Cable acts like a coil and generate magnetic field. There are different ways available to remove or minimize the power frequency magnetic field from the device are given below. Use conductive shielding. Use ferromagnetic shielding. Passive compensation removes the magnetic field. Also do active compensation. Design modification of electrical facilities and equipment. Use magnetic shielding foil. These tests relate to the immunity requirements for equipment to unidirectional surges caused by overvoltage from switching and lightning transients. Several test levels are defined which relate to different environment and installation conditions. These requirements are developed for and are applicable to electrical and electronic equipment. Common problems in surge immunity of devices, given below. Surges generated due to lightning strikes, power outages, tripped circuit breakers, due to the short circuits, power transitions in other large equipment on the same power line, malfunctions caused by the power company, electromagnetic pulses with electromagnetic energy distributed typically up to the 100 kHz and 1 MHz frequency range. Inductive spikes due to magnetic and inductive coupling. There are different ways available to remove or minimize the surge entering in the device are given below. Use lightning arresters to protect device from the lightning surge. For suppressing surge, use transient voltage surge suppressor. Use metal oxide thyristor to protect the device from surge. Use thyristor surge protection device to protect the device from surge. Gas discharge tube also used to protect device from surge. Use of selenium voltage suppressor for the protection device from surge is very important. Also use carbon block spot gap over voltage suppressor. Use quarter wave coaxial surge arrestor. Also series mode surge suppressors are important against surge problems. Voltage dip is drop in line voltage up to the certain level of AC mains voltage and are caused by faults in the network, in installations, or by a sudden large change of load. In certain cases, 2 or more consecutive dips or interruptions may occur. Electrical and electronic equipment may be affected by voltage dips, short interruptions, or voltage variations of power supply. In this test we can test the immunity of device to the voltage dip. Common problems in voltage dips and short intervals immunity of devices, given below. Voltage dips are generated due to the faults in the equipment. At the time of motor starting, voltage sags are produced. Majority of the sags are mostly caused by the power system faults, due to the operation of reclosers and circuit breakers, due to the bad weather, due to the pollution, vehicle problems. There are different ways available to recover the voltage dips entering in the device are given below. Use of tap changing transformers. Use static voltage regulator. Ferro-resonant transformers. Uninterruptible power supplies, battery storage, flywheels and motor generator sets. Compressed air energy storage. Dynamic voltage restorer is used to restore the voltage. Use electronic voltage regulators. For three-phase equipment, use magnetic synthesizers. Inductive loads such as relays, switch contactors, or heavy-duty motors when de-energized, produce bursts of narrow high-frequency transients on the power distribution system. These fast transients can also be produced when the utility provider switches in or out the power factor correction equipment. That transient voltage is effect on the equipment. So in this test we can test the immunity of equipment for the transient voltage. Common problems in electrical fast transient voltage immunity of devices. Given below. EFT pulses are generated by sparks on AC mains and occur whenever an electrical switch opens or closes, or when a motor commutator is running, powering up or powering down. At the moment of switching there is an infinite d by dt due to the variation in the load, due to lighting, because of capacitor switching. There are different ways available to remove the electrical fast transient voltage entering in the device are given below. Filter the incoming EFT current by installing a ferrite core around the cable carrying the incoming current. Use shielded cables. Shielded cables can limit the EFT current that enters your UT because EFT-induced shield currents can be diverted to the chassis. A shielded cable works best when you can roll its shield braid back over the insulator before attaching the cable to a connector. The PCB layout prevents large interference voltages from appearing within the circuit. Internal circuit design is bandwidth limited wherever possible. Interfaces must be filtered or screened to a structural low impedance earth so that common mode pulses are prevented from entering the circuit. Optimize power and signal connections for transient suppressions at the point of entry by keeping the wires as short as possible or by twisting supply and ground. Do not route filtered and unfiltered lines in a single cable bundle or close to each other. Keep the lines from noise generators such as relays and inductive loads away from sensitive lines such as low-level analog signals and communication lines such as I2C, SCL, SDA, and UART. Employ good soldering of wires or components. Improper or dry soldering will increase the inductance on the path. A good design should have the least inductance on the current path. Refer to Electronics Assembly Standard IPCA 610F for more details on the soldering practices. Use MOV for EFT suppuration. Also use TVS diode. Thank you very much for watching the presentation of common problems and solutions in EMI or EMC testing.